Hey guys, just a quick rundown of the diag we did today. As you can see, it's a Nissan Patrol with a 3 litre and the airflow meter open or short. Yeah, we know that airflow meters on these can be a problem, and it's probably reasonable to assume an airflow meter problem straight up and not a wiring issue. Just want to highlight what we actually go through in order to prove this out sort of beyond doubt, so that you know that you're putting the right part or the right repair into the vehicle. Some people will sort of see this as, yes, that's what they already do. This is probably more so for the guys just getting into diag and the guys just getting into the trade. So first up, drive the car, and I mean, I didn't have to drive more than 20 meters down our driveway to know that this was down on power and we had an issue. The second step is pull codes. Step 3 for us, while the tool is already there, is to have a look at live data. So we'll just go back through. I've got some screenshots of what we did. So this one's pretty obvious. The MAF is pegged at 1.02 volts, even with a couple of throttle snaps, and you can see we should have an airflow increase with that. So we go through just a quick visual of the harness around the airflow meter, what we can see, just to make sure that nothing is stupidly wrong with the car. We go to the point now, after we've done the test drive, the scan tool, the codes, the live data, the basic checks around the engine bay to make sure that there is nothing stupid wrong with the car. I go straight to the computer and start actually just looking at what in fact we're dealing with. So I've laid out what I print off for myself when I go into a job like this. So one is the wiring diagram. You can see I go through and highlight all of the relevant wiring. So this end here is all the ECU grounds. MAF sensor is up here, and I go back with the highlighter from the sensor back to wherever the wiring goes. So in this case, there is a lot of wiring over to transmission modules if it's an auto. The wiring is shared a lot with sensor grounds and sensor powers, and it can be very handy to just sit down and fully understand the circuit that you're working with. Because we had a short or open, our main concern is actually pin 35, which is sensor signal, but you can have, because all the wiring's in there, you can have short between wiring, you can have opens in an individual wire. You know, the code doesn't necessarily mean that that particular wire is actually going to be the problem. From there, after we understand the circuit that we're looking at, I go through whatever other information we can get. So connected diagrams so that we know where we're at, and then pinouts. And I basically just work back from the wiring diagram to the pinout information and highlight across anything that is associated with the airflow meter wiring for a really quick reference, and then I get a pretty good idea straight away of where all the wiring goes, what we should see on each pin, so that we have a thorough understanding of what we're dealing with, because we can't diagnose or repair anything that we don't understand how it works. From there, this whole process was a matter of multimeter testing, in which case I actually used the multimeter function on my motor scope because it was handy, and we basically just went back and checked that we actually have sensor grounds, which is a matter of unplug the connector and testing from the pin in the connector back to ground. Make sure that we've got the sensor 5 volt, and make sure that there is continuity for a start on that wire from pin 35 to, in this case, pin 1, continuity, and check that wire for short to ground. and it doesn't hurt. Generally, you're not going to see the short in the harness from that wire to another wire. Generally, if that's the short, it's going to be in the sensor itself. And in this case, I didn't actually even test the sensor. Basically, the problem was going to be in the sensor, or it was going to be in the wiring. So once we proved out that the wiring was intact, for me that's enough evidence that the sensor is the problem. So in this case, we grabbed a sensor through CoolDrive for quite a reasonable price. Came from with AFI being part of CoolDrive now, so we ended up with an AFI sensor. Let's press that again, and we can see that RPM and MAF, we now actually have the MAF sensor responding to changes in RPM. So problem solved. And for good measure, what we do is also take another code scan, and in this case we get 55 system OK, because when I talk to the customer, everything that I've just run through now, all of these printouts, all of this scan tool screenshots, all of this stuff I talk to with the customer so that they have as good an understanding as they're going to have of what the problem is, why we did what we did. And when you go through and you put the scan tool in front of them and show them the information, you put these printouts with all of your highlighting, and I actually run a notebook on my diagnostic bench as well, where I jot stuff down, test results, etc. And as messy as my handwriting is, I put that in front of the customer as well, because I need them to, we need them as an industry to understand what it is that we do when we're diagnosing their vehicles. And when you put all of this information in front of them, the fact that this guy just paid me $450 to diagnose this and fit a airflow sensor to his car, the price for him was irrelevant because he could see the value in what he was getting. So part of diagnostics is not just a thorough test procedure and being confident in the repair, is relaying what you've done to the customer, and it makes a diagnostic charge a seemingly small amount. So this guy paid $160 plus GST an hour for my diagnostic time, and I charged him a full hour block. He was okay with that, and he was okay with the cost of the repair. So just have a think about it, and we'll go from there.